Hello friends, welcome to JavaEE EJB JPA tutorial. Now we are starting a new subseries JPA-QL, Java Persistent API Query Language. So in this subseries we will create an example, and in the meantime we will learn how to write a JPA-QL, Java Persistent API Query Language. In this video, we will learn the concept of JPA-QL. So as usual, there are prerequisites. So you are watching the subseries part by part. So this is a subseries 6, and here we are continuing from our subseries 3, 4 and 5, and here is the 6, and in this subseries we are going to learn JPA-QL. So JPA-QL stands for Java Persistence API Query Language. JPA-QL. So Java Persistent API Query Language. Since in our tutorials we are using SQL Server, the native query will be in MS SQL, Microsoft SQL language. So MS SQL is not portable, we know it, among various databases. Say for example, if we use MySQL, MS SQL, Oracle, so there may be some structural difference when we are forming the SQL. So SQL is itself a standard, but still there may be some deviation that makes it somewhat difficult or revisiting the native queries when we want to port it from one underlying database to other one. So JPA-QL is one layer ahead of native query. So native query here refers the underlying database language. It can be a Microsoft SQL Server, or it can be a Oracle or other famous database, and we call that as a native query. And JPA-QL is one layer ahead of the native query. That means this will be the JPA-QL, and underlying one is the native query. So this native query can be anything. It can be a SQL Server, or it can be a Oracle, as already told. So on top of a native query, there will be a JPA-QL. So JPA-QL will be converted to native query before execution. That means we write something in JPA-QL. Here we will place our query, still a string, just like how you form your native query. The same way you will form a JPA-QL, and during the execution the underlying database understands the native query, right? That means here the conversion takes place. JPA-QL will be converted to the native query. So that depends on what DB we are connecting. So JPA-QL will be converted to native query before execution. Let's see an example. Here if you see savings account, so this is the entity name, SAC is the alias, select SAC. Here we are giving the alias name. So this alias name tells that we are selecting the savings account entity. Select saving account entity from savings account. So for now, let's assume that the database, so this is the entity, right? This will be linked to a database table, let's say savings AC. So if we assume this returns 20 records, or the table contains 20 records, so this is JPA-QL, right? So the native query will be in MS SQL, since we are using Microsoft SQL Server. The converted query, if you see, select star from savings account, and that returns 20 records. So these 20 records is converted into entity, because if you see, JPA-QL sits on top of this native query. So once we feed this information, the JPA-QL will get converted into native query language. Native query language returns number of records. Here 20 records we can say. And when it is converted, it will be 20 entities. Entities, we know it is a plain Java class instance. So since we need to return as a single unit, we will get list of savings account. That's the entity, right? So for simplicity, we will say SSC. So that's what it will return. Native query returns number of records, 20 records, and JPA-QL will return list of entities, and the entity counts 20. So in our previous example, we know that the find method of the entity manager can load one entity instance via primary key or a key field. So the key which we pass to the find method will pick one record from the database, forms a entity, returns back to us. We used it many times in our previous example for update as well as delete action. In case of update, what we do, we perform a find, we return an entity, and from that entity we will make a field update. Towards the end of the business method, the entity manager will issue a native query execution. That will be an update. So for delete, we know that we mark the record for delete, and towards the end of the transaction, delete will be issued. To retrieve multiple entities, that means in all our previous example, we returned a single entity using the find method. So if we want to retrieve multiple entities, we will use JPA-QL. So just now in the previous slide, we saw JPA-QL that returns 20 entities. 20 we assumed, but that will give an idea of how multiple entities are returned using the JPA-QL. And we already know from our previous slide, JPA-QL is portable, since it converts the JPA-QL to the underlying database native query language. JPA-QL is portable. That means once you write your JPA-QL, and at present if it is converting the JPA-QL to MS SQL, later we can simply switch the database to Oracle, so the conversion still takes place. So that's why here we are saying JPA-QL is portable among all famous databases. The createQuery method of the entity manager will return an query object. So these two are the heart of this subseries, and we will use it many times. So the createQuery method of entity manager will return a query object. The method takes a string representation of JPA-QL statement. So createQuery method is called from entity manager by supplying the JPA-QL statement. So when the JPA-QL statement is valid, the entity manager's createQuery method will return an query object. From that query object, we can perform various other operations. I mean the database operations. Any syntax error. So here JPA-QL statement we are stating, right? That means it's a string. So the string should adhere to a specific syntax of JPA-QL. If not, we will get illegal argument exception. From the returned query object, you can invoke returned query object. In the sense, here we are talking about this query object. The query object will get returned by the entity manager's createQuery method, and the createQuery method depends on the JPA-QL statement. So from the returned query object, you can invoke various methods depending on the supplied JPA-QL. So the JPA-QL can be for insert, it can be for update, or it can be for delete. So based on the JPA-QL, you can access various other method from the query object. Alright, so the createQuery method returns query. We know that createQuery method is from the entity manager. When JPA-QL is for, so that's what you feed for this createQuery, right, to get the query. So if it is for update or delete, from the returned query object, we will make a call to execute update method. So the execute update method will return a number, and that number tells how many rows gets affected by the supplied JPA-QL for update or delete. So it may update one record, or it may update multiple records. Same goes for delete. So that we can know based on the return value of the execute update method. When JPA-QL is for select, you can use get single result, or we can use get result list. So the execute update method will be used when the JPA-QL is for update or delete. But when the JPA-QL is for select, that means a select statement, if you pass it to the createQuery method, from the returned query object, you can make a call to get single result or get result list to retrieve the result of this select action. Get single result is to retrieve only one entity. So when we are writing the JPA-QL, the time itself we know the query will return single or multiple. Say for example, if we write a JPA-QL based on a key field, we definitely know it will return a single record. And it may not be a key field, I mean the query involving key. Sometimes we know by the where condition itself, by making a different combination, we know that the query will return single result. In that case also, you can use get single result. It will be fast. So you can still use get result list also, but unnecessarily we will get a list with a length as 1. That means there will be a list of entity that contains only one item in the list. To get multiple entities, we can use get result list. This method packs entities in a util.list and returns it. So this is what the entity manager does. It makes use of a list from the Java util package and packs the entities. So which entity depends on the JPA-QL. So in the example previously, we saw that select SAC from saving account SAC. There saving account is the entity name. So if it returns multiple records, then we will be having a list of the entity savings account. So that's all here in the theory part. There is no demo here, and from the next video onwards we will start our example. That's all here in this video. Thank you for watching. Bye.